Okay, lesson 6 here, we're just going to do more displacement problems. So basically the same problems we've been doing. Some of them are just a little different. I'll show you a couple examples of ones that are a little different here. Okay, so here's example 1. An object accelerates constantly. One thing I'm going to have you do is start turning your notes in. So can you make sure you're getting this copy down, and then you're going to turn in a copy of this for points. When you turn in your assignment, you'll just also turn in a copy of your notes here. So make sure you are copying these down to get points for them. That's a way of showing you're doing your work. Okay, initial velocity is 0. Or it could say starts from rest, travels 20 meters in 3.2 seconds. We did one like this already, but I just wanted to review it. What's the acceleration? Okay, here's your formula. Draw out the picture. Starting and the ending is always what the picture is. X0 is 0, starting at 0. V0, the initial velocity is 0. A is what we're trying to figure out. The x at time t, which is this ending x, is 20 meters. And the time here at the end, 3.2 seconds. All right, if we plug into that formula, these two, these two are going to be gone, right? This is 0, this is 0. The only thing we're really worried about is this ending part. Oops, there, 1/2. A, the t is 3.2 seconds squared. So you're really just solving this out for A. These are gone. A, 3.2 squared is 0.6. No, that's not right. 3.2. Oh my goodness. 3.2 times 3.2. 10.24. Seconds squared. Divide each side by 10.24 and then also times by 2, right? Seconds squared. I could also say and times by 2 to cancel out that half. Times by 2. So you can just work that all out. 20 times 2. Divide that by 10.24. And notice the units, I'm getting 3.9. It's meters per second squared. So it works out to the correct units for A. Okay, let me show you one other one. This one's a little different. This one says an object is dropped from a 30-meter tall building. So an object dropped from 30 meters. How long does it take? To hit the ground. Okay, we're always assuming on these, if it's dropped or thrown up in the air, that A is negative 9.8. Okay, so A equals negative 9.8. You do need to draw out a picture on all these, okay? Drop there. Where you can either define 0 height to be here or here. I'm going to define 0 height here, down at the bottom. So this height, starting height is actually 30 this time. Starting velocity, it's starting from rest because we're dropping it. The x at time t, that's down here at the bottom. The position at time t is down here at 0, actually. I defined this to be 0 meters, the bottom of the cliff. And what else do we have? A is negative 9.8. I think that's everything we know. All right, let's look at our formula. Okay, right there. And we can just start filling stuff in. X of t is 0. The x0 this time is 30. V0 is 0 times t, which still will be 0, and then plus 1/2 times negative 9.8 meters per second squared times t squared, right? We are trying to figure out t. All right, the good thing is this is gone, so that helps us out. I'm going to just minus the 30 over already, make it a little easier actually. All right, so we got negative 30 meters on this side. We've got a half times negative 9.8 meters per second squared times t squared on this side. Let me turn this light off, see if it's easier. So there we go. Okay, I'll distribute the half in there, or multiply the half there, negative 4.9. T squared, divide each side by negative 4.9. Okay, so 30 divided by 4.9 is 6.12. I'll go to 2 decimal places here, and then at the end I'll probably round it down to 1, but equals t squared, right? Look at our units here. This is meters per second squared. This actually comes out to seconds squared because this comes up on top, the meters cancel. In any case, when you do a square root, you're going to get down to just seconds. So I need to do square root of that. And I'm getting 2.47 seconds. Really round that to 2.5 since we're generally rounding to 1 decimal place. Okay, so pretty much the same problems, this kind of problems here. We're just kind of doing more practice, just get a few more reps, and we'll make it a little more advanced on the next assignment. All right, keep at it. If you have any questions, just email me and we can go over stuff.